Hello everyone, thanks for coming. So in this week, we mainly discussed the evaluation and the calculation of binomial trees. And we also discussed briefly the Ito formula and the stochastic process. Because we have discussed and reviewed the binomial trees in last week's and this week's discussion session. So I would like to give a brief preview of the Ito formula and Black-Scholes model, because in next week, it's our final week, and perhaps we're going to do some brief review. So first, we define the winner process. The winner process has independent increment, is a stochastic process, and the increment delta z is epsilon square root of delta t, where epsilon is a normally distributed random variable. So here we can see that delta z is of order square root of delta t, and this winner process is thus not differentiable. The generalized version is dx equals to a dt plus b dbt, where bt is a winner process. An even more general version is a E2 process. So for E2 process, we have dx equals to a dt plus b dbt, where bt is a winner process, but here the coefficients a and b can depend on both x and t. For instance, for the process that defines the stock price, we have ds equals to mu s dt plus sigma s dbt. This can be used to approximate the stock price by discretizing time. Next, we have the well-known Ito formula. As an example, suppose that S is the price of the stock, and G is the price of a financial derivative that depends on the stock. So we can write dg equals to a partial g partial s dt plus partial g partial t dt plus b partial g partial s dbt. So this is a stochastic term plus the second order term, b squared over 2 partial square s partial s squared dt. So in our course, the most important formula for determining the movement of stock price is ds equals to mu s dt plus sigma s dbt. This can be used to evaluate the price of the forward contract. And also, if we define G to be the logarithm of the stock price, so G is called the log normal. It is called the log normal distributed. In next week, we are going to discuss the Black-Scholes model. So for the Black-Scholes model, we can derive the expectation as well as the variance of the stock price. The expectation is S0 e to mu t, while the variance is S0 squared e to 2 mu t e to sigma squared t minus 1. We can also calculate the expected return distribution of the stock. So st equals to S0 e to xt, where x is a normally distributed random variable with mean mu minus square sigma square over 2, and the variance is sigma square over t. So note here the expectation of x does not equal to mu, because if the expectation of x is mu, then the expectation of st is larger than the theoretical value. Thank you.